Hey guys, hope you're having a good weekend. I'm Miss Smith, and we're going to go over how to do linear systems of linear equations in word problem form, so applications. The first one we're going to look at is number 1. If you have your worksheet, your homework that you're supposed to have picked up on Friday, go ahead and get it out because we're going to go through this. Write it down as you follow along. I'm going to tell you to pause the video and fill it out as you work. Okay. Tickets to the concert were $2.50 for adults and $1 for students. $1,200 was collected and 750 tickets were sold. Write a system of linear equations that can be used to find how many adults and how many students attended. How many students attended? All right. So the first thing I'm going to do is I'm going to underline key information. $2.50 for adults, $1 for students, $1,200 was collected, and 750 tickets were sold. So, we know what the first one, we kind of have an idea what the first equation is going to be. I'm going to go ahead and define my variables. Okay. X is going to be adults. Y is going to be my students. And if you used A and B, you can also do that. Those were also assigned there. And now I'm going to set up my first equation. My first equation is going to be $2.50, and I'm going to do this in money so you guys can see this. That's for adults. So 250x plus $1y for students is equal to, what do you think, $1,200 or $750? $1,200 or 750 tickets? If you said $1,200, then that is correct. Dollars go with dollars. Okay. Now, how do we represent the 750 tickets? Well, we know that 2 types of tickets were sold: adults and students. So combined, adults plus students is equal to 750. At this point, go ahead and pause the video, see if you can solve this system now. All right. If you've attempted to solve and you can't, here's what I would do. I would take this bottom equation and I would multiply it by a -1. You could do a -250, but I'm going to go ahead and eliminate my y's because they're both the same sign. If I just go ahead and do the opposite of that, I can get the y's to eliminate. So 2.50x, so 250x plus 1y is equal to $1,200. And then the bottom equation is going to be -1x minus 1y equals a -750. Now, I'm going to eliminate the y's, and I'm going to go ahead and continue solving. So, 250 minus 1 is 150, and then 1,200 minus 750 is 350. Oops, I forgot my variable. So now I'm going to divide both sides by $1.50. X is equal to, it's either 450 or 300. I'm trying to find my notes. It would be 300. Pause. Okay, I made a mistake because I went too quickly. 1,200 minus 750 is 450. So when you divide that by $1.50, you get 300. My apologies. Okay, now that we've gotten 300, I'm going to take that 300, plug it in place of x. So 300 plus 1y is equal to 750. Subtract both sides by 300. 1y is equal to 450. So, how many student tickets were sold? 450 student tickets. And that's my answer to this system of equations. All right, so number 8 or number 2. Abby filled her goodie bags with 4 cookies, 3 candy bars, and spent a total of $10.25 per bag. Marissa filled her goodie bags with 2 cookies, 7 candy bars, and spent a total of $14.75 per bag. Each cookie costs the same amount. Each candy bar costs the same amount. Write a system of linear equations that can be used to find the cost of one cookie and one candy bar. What was the cost in dollars for each candy bar? This is what I was telling my students. When you see this, go ahead and mark an X above what you underlined. Okay, that's 4 cookies because X is cookies, Y is candy bars. So X cookies, so 4X, 3Y, and a total of 1025. So 4X plus 3Y equals 1025. And that's what I'm doing right there. I'm just simply interpreting what I've underlined. And then the second equation will be 2X, because the cookie's right there, 7Y, and then equals 1475. So I'm going to take all that information that I just put down there and put it into my box right here. Are you ready? 4X plus 3Y equals 1025. 2X plus 7Y equals 1475. Okay, that's your system. Pause the video, see if you can solve it by elimination, see what you get. If you are not going to pause the video, I'm going to continue on. 4X plus 3Y equals 1025. 2X plus 7Y equals 1475. I'm going to multiply this top equation by 2, this bottom equation by a negative 4. Why did I do that? I couldn't find anything that they shared, so I'm going to go ahead and do that. I'm going to make sure I don't make a mistake this time. Uh-oh. And I'm going to write this out. Here we go. The top equation becomes 8X plus 6Y equals $20.50. The bottom equation becomes a negative 8X minus 28Y equals a negative $59.00. The X's cross out, leaving me with negative 22Y equals a negative $38.50. Divide by negative 22 on both sides. Y is equal to $1.75. Now, whenever we get decimals, we have to ask, what are we asking? What is the context? The context is cost. Is it okay to have a decimal in your answer? Yes. You need to make sure you're rounding to the nearest cent so that we don't have anything crazy. I can give you $1.75 back. I cannot give you $1.75, 3.456. It's $1.75 and $1.75 only. Plug that back into my equation. It doesn't matter which one, pick one. 4X plus 3 times 1.75 is equal to 1025. Okay, now I'm running out of space over here, so I'm going to rewrite that real quick. 4X times 3.175 is 5.25 is equal to 10.25. Subtract both sides by $5.25. 4X is equal to 5. Divide by 4. X is equal to $1.25. So let's answer this in context. Okay. What was Y? That was the number of candy bars. So each candy bar cost $1.75, and then each cookie cost $1.25. So I'm going to say $1.25 per cookie and $1.75 per candy bar. That's my answer. On the back, what I'm going to do is set these up for you and give you the answer. What I would like for you to do is work them out. That way this video isn't a million times longer than it needs to be. So I'm just going to help you set this up. Good seats were $5 each. Poor seats were $2 each. 210 people attended and paid a total of $660 for all of the tickets to the game. Okay? G, good seats. P, poor seats. If you want to use X and Y, you absolutely could. If you're doing that, I would do good seats X, poor seats Y. All right. So, and nosebleed seats, like ones that are way up in there, up in the stands. This would result in the following system of equation. 5x plus 2y is equal to cost equals cost, so $660. And then we have 210 people who attended. So the number of tickets, x plus y, is equal to 210. That is my resulting system of equations. You should be able to solve that one fairly quickly. The bottom one. Gerald bought 9 hamburgers, 3 orders of french fries, for a total of $24.75. Chris brought 6 hamburgers, 4 orders of fries, for $19.50. They all cost the same. Write the system. Hamburger H, fries F. So that would be my X, this would be my Y. So the resulting system of equations here would be 9x, okay, 9x plus 3y is equal to $24.75. 6h, oh, I wrote 8. 6x plus 4y is equal to $19.50. This one's going to take you a little bit of practice. This one's going to kind of stretch you a little bit. Multiply the top equation by 6, the bottom equations by a -9. You will get a really cool answer of, let's see here, $1.50 for french fries. That's your Y, $1.50 for french fries, and then $2.25 for hamburgers. Okay, that's going to be your resulting answer there. This top equation, I don't think I gave you the answer. So the answers for this one would be 15 good seats were sold and 195 for the other seats. Okay, for the poor seats. Those are your answers. See what you get. You have a good rest of your weekend. I will see you in class on Monday.